Hello, my name is Graeme Clarke. I'm a Solutions Director and Global Head of DevOps at Expleo. My background's in software development, and I've been around now for about 25 years, both as a developer and as a manager. For those of you who don't know us, Expleo are probably the world's largest software quality consultancy. We're active in 30 different regions, 26 different business sectors, and we've been here in Ireland now for about 20 years. Now, I've had the opportunity to speak before on low code, and I've attended a few presentations that are nice and warm and fuzzy and quote some great numbers from Gartner. And most of these are given by excited young grads that have managed to create a low code application. Well, I'm sorry, but I'm not here today to talk about that stuff, because I believe that low code can actually be a real danger to your business, as there are a number of factors that can very quickly and easily go horribly wrong with devastating consequences, even to the point where 30 years on, you are still dealing with the fallout. So what I'm going to do today is I'm going to start with a bit of a background to low code, and I'll quote some of those numbers from Gartner. And then I'll talk about 3 areas where low code can go wrong: agility, extensibility, and operations. But it's not all doom and gloom. I'll also cover the silver lining and give a few tips for how you can make low code work for you. So let's get started and look at a bit of the background. Now, what is low code? If I go onto Wikipedia and I look it up, it will tell me that a low code development platform is a graphical user interface that allows me to create software. So I can drag and drop elements onto the screen to create an application. And in terms of some of the numbers, Gartner tells us that low code will grow by 23% worldwide this year. So it's very popular. Forrester tells us that it will enable us to deliver software 10 times faster. And OutSystems, who are a low-code provider, tells us that the reason is that it will reduce the number of steps in the software development process from 16 all the way down to 7. But why on earth do we need this stuff? Well, I'm sure we've all felt the pain of trying to find software developers, especially in the current COVID-19 climate. They're hard to get. And in the US today, there are 500,000 open software development positions. You may also be struggling with time to market. Maybe you're losing market share because your competitors are always one step ahead and they can update their apps and products faster than you can. Perhaps they're using low code. Or maybe you have a gap in understanding. Maybe your developers are producing code which doesn't really match the original requirements. And if you could get your marketing guys or your BAs closer to the dev team, then the applications would be more like what the end users are looking for. And what is claimed is that with low code, we can produce more valuable applications far quicker and at a fraction of the cost. Now, don't be fooled into thinking that low code is some new invention. It's a silver bullet that's just come along in the last year or so. And in fact, Forrester coined the term low code way back in 2014, but it's been around a lot longer than that. Back when I started out 25 years ago with C++ development, we had low code back then. And one of the earliest implementations was actually COBOL. Now, I'm not going mad. Back when we were doing C++ development, it was complicated and hard to code in, and you had to have expensive, experienced engineers who knew what they were doing. And COBOL was created for accountants with a syntax that was very close to plain English. And the idea was to open up programming to business people, reducing the need for expensive software developers and making it easier to build applications. Now, I'm sure that many of you here today will be using COBOL in your legacy backend systems. And typically these systems are extremely complicated and nobody dares touch them in case the whole thing will come crashing down around us. And this is exactly the opposite of the vision for low code and for COBOL. So how did it go so drastically wrong? And how can you avoid the same pitfalls in your low code implementation? So let's look at some of the problems, and we'll start today with agility. Now back in the day, development in C++ was complicated and time-consuming, and it required careful planning. And waterfall processes with long thought-out phases made a lot of sense. But as the speed of development increased, we needed new ways of managing projects, and that's why Agile came along. Now, one of the features of Agile is the ability to release working software in short iterations, typically called sprints. And what you do is you take a much smaller set of requirements, we design, develop, test them, fix all the bugs, and get them out into production. And by getting the software out quickly, the sprint allows us to realize value early and rapidly respond to changing requirements and new business priorities, which of course is why it's called Agile. Now, I'm sure many of you have tried Agile and it hasn't worked out very well. And one of the reasons for this is that although the speed of development has increased, many people have found that the speed of testing has not. And what happens is that the team struggles to get all the work tested and the bugs fixed before the end of the sprint. And work spills out over into the next sprint, causing the release to be delayed. And I'm sure we've all heard the famous saying, you know, it works on my machine, shame it doesn't work in production. And worse still, this starts to compete with new work coming in, and the development team starts the next sprint and starts to build something new on top of unstable code, potentially riddled with bugs. Now, this graph is from a failed Agile project, and it shows the number of active defects in the system over time, with these black lines representing the end of the sprints. The team is unable to get the software out at the end of the sprint. Change request coming in at the start of the next sprint is competing with the bugs. And we get this exponential buildup of bugs in the system. Now, as the number of bugs and change requests go up, so does the stress, while the quality, the return on investment, and the value plummet like stones as the release dates get pushed further and further out. Everybody will be running around like headless chickens trying to get bad quality software released. And by the way, they'll be forgetting about things like reporting or documentation. So if you're a CIO or a senior management, you will lose visibility and control really quick. And you know what? Guess what? With low code, it's going to be releases becoming 10 times faster than that. Now, many companies have tried different approaches to solve this issue. Some people have brought in test automation, which is great in itself, but the problem is the tests still need to be written and maintained. And typically with traditional approaches, these tests are written in languages like Java or C#. And this requires software development skills. And you know what? Devs don't like writing tests, and they're also too busy writing the actual code. So in many cases, this approach hasn't worked out. Other companies have decided to reduce or even eliminate parts of the development process altogether. And there seems to be this sort of idea that if you do work in small enough increments or use extreme program, well, you don't actually have to test or design your software, and somehow a stable, maintainable software structure will magically appear out of the ether. Companies that go down this route typically get hit with spiraling amounts of technical debt, making their applications more and more unmaintainable. Other companies have gone back to waterfall or some weird kind of hybrid where they've combined extensive requirements and project management documentation with all of the agile ceremonies. And what happens to the teams get squeezed between having to write so much documentation and attend so many meetings. There's no time to do any actual real work. And this approach is normally called Wagile, or to give it its proper name, a death spiral into hell. Is your agile process robust? Have you got a handle on your software testing when you're going to need to have if you're going to shift to low code? Now, let's move away and talk about extensibility. And I'm sure many of you will be familiar with the extensibility challenges of low code, as many of these platforms are very restrictive. You may find that the application doesn't actually match your corporate branding. It's missing controls or features that you need in the UI, or maybe it's not going to process the data in the right way. But the good news, of course, is that there are many options available to sort this out. You could write CSS code to customize the style and the look and feel. You can build new client-side controls in languages like JavaScript, and you can even develop new APIs in the back end using languages like C# and Java. Now, one of the problems is that we will have to coordinate and manage all of these things together, and that starts with the development teams. And many companies will be using citizen developers. These are guys like BAs or marketing guys that understand the business context, but they're certainly not going to be able to code back-end APIs in Java. For this, we need, of course, our software development team, people that are used to the rigor and discipline of engineering best practice. And we probably also have content developers or copywriters somehow sitting in the middle. to deliver the software successfully, we will have to coordinate all these people together who have very different working practices and have them come together as a single team. Believe me that this is more difficult than it sounds, especially when the speed of delivery is increasing like we have with low code. But the technology itself poses even greater challenges for extensibility. We need to make sure that we can develop new versions of the low code while maintaining and fixing bugs on the current release. Now, this is called configuration management, and there are typically three main features. The first one is source control, and that allows us to perform incremental backups of the software. We also have branching, so I've been able to work on concurrent versions at the same time, each with their own history and change control. And of course, we have versioning, being able to tie new features, bugs, tickets down to a single build of the app. Now, many of the low-code platforms don't have any kind of source control integration and don't even support configuration management. In some cases, you cannot even export or back up the low code, which means you are completely at the mercy of the provider if something goes wrong. If you cannot version the code, if you can't have multiple branches, if you can't work on multiple versions at the same time, how on earth can you use this stuff in production, especially if you have SLAs in place with your clients for the turnaround of issues? All right, let's move on and talk about operations. Now, I worked with a BFSI company last year. They'd brought in low code. The POC was great. They deployed an app to production using a BA. There was about 5 users. It was fantastic. And on the strength of that, they decided to release this to their entire user base. What a disaster. On the first day, more than 10,000 people logged in, and this is what they were greeted with. It is the dreaded 404 or resource unavailable. And unfortunately, they'd chosen a provider which hosted the low-code application in the cloud, and it wasn't able to handle the increased load. And all their own support team could do was raise tickets with the provider, who unfortunately had a 48-hour turnaround time in their SLA. It was completely embarrassing. And even having part of a company's operational systems outside the corporate network is a big problem for many CIOs. For example, how does this thing actually access databases or API gateways within the network? What sort of security holes do we have to open up? Many of these low-code platforms are built on JavaScript frameworks that are extremely vulnerable to things like cross-site scripting attacks, and they rely heavily on third-party integrations that can bring a whole raft of unwelcome issues. And what about things like GDPR? What guarantees will these providers give us concerning removal of personal data from their tool in case of some breach? Will any information actually entered into the platform be secure at all? Now, I hope I haven't deterred you from low code too much. And to be honest, I've just scratched the surface. We haven't even talked about the nightmares of low code licensing, cross-browser and device compatibility, or whether or not these providers will even be around next week, never mind in 10 years' time. But I want to move on now and talk about how some of these things can actually be overcome. And I'll start with agility. And when I talked about agility, I focused on one aspect, which was the speed of testing. Now, I don't mean the speed of executing tests, because with automation, that should be pretty quick. But what I do mean is, first of all, the speed of creating the tests, the amount of time that we're spending maintaining the tests, and also shifting the testing left so that it can start earlier on. And these things can be facilitated by picking the right test automation technology, and in particular, one that is AI or artificial intelligence enabled. And a good example of this would be Micro Focus UFT1. And UFT1 brings us a number of key features. And the first one is advanced object recognition. And the AI control the application and locate all of the various elements in the screen which appear as objects for the tests to use. And this eliminates the need to create things like page object models or other test artifacts, reducing the amount of time to create tests. I've also got self-healing test cases. If something on the screen changes, like a font or a color or position, then the AI is smart enough to realize it and still make the tests work. And this removes the need to be constantly updating tests with every minor change to the screen, and will take away a lot of the manual effort. We've also got cross-platform support. It will make sure that the same set of tests will work across all browsers, OSs, and mobile device types. With traditional approaches, tests may need to be duplicated, perhaps with subtle changes or complicated configuration, and the AI will remove that requirement. And it's not just a tool. We need to combine the tool with the right testing approach, like test-driven development, to ensure we can shift everything left and allow testing to start earlier on. Now, talking about extensibility, there is no getting away from it. Many low-code platforms are effectively toys to knock up internal apps. And if you want to put production software out there in front of your clients, you need the platform to provide a proper export or source control integration functionality. Now, an example of a good platform that does things right is the Neutrinos platform. This is one of my favorite low-code platforms, and what it can do is it can export the entire low-code application into Angular JavaScript, okay? So you get access to all of the code, and that allows us to check the code into our source control, okay? And that enables all the traditional practices of branching, versioning, and configuration management to be applied to the low code in exactly the same way as traditional software development. This is going to facilitate the extension because the software developers don't have to just try and extend it. They can work directly on the underlying code, making it easy for them to modify controls, add new ones, change the look and feel, fix performance issues, or anything else that needs to be done. And it's also going to facilitate, it's going to reduce the gap in working practices and facilitate management, because it means we will be using the same processes and policies across the board for versioning and branching, and that'll help to sync up our teams. Now, platforms that allow low code to be exported in this manner also make it easy for us to host the low code applications ourselves. And what we can do is we can host them on the same servers that are running our existing websites, so that the low code app benefits from similar levels of performance, and it ensures that our operations and development team can access the stuff in case there's any issues that need to be handled in a timely fashion. And it also means that we can link in our own Active Directory or Office 365 for things like single sign-on to improve the security. It becomes also much easier to test this stuff for security in general, because we can run SaaS checks on the code and software composition analysis, which will detect vulnerabilities in the third-party libraries that these things use. And this can be done using the traditional sort of CI/CD or DevSecOps pipelines. And we can bring to bear tools like Veracode, which will run instant security tests on the code every single time that anything changes in the low code or the supporting controls or the backend APIs. And this is exactly the same as we would do for a traditional full stack application in something like Java, and it will give us the confidence that the application will be secure. Now, that's great. It's a good theory, but I just wanted to talk through a quick example of this being done in practice. And we had an account there last year with a US insurer, and they wanted to adopt low code to reduce their release timescales. They had to get a whole raft of new insurance policies available for quotation and purchase online due to the COVID crisis. And they had the typical challenges with low code. The platform had issues with configuration management and backup. They'd also tried this themselves with a few BAs, and it hadn't worked out. So we deployed a low-code team, and our Expleo team was staffed with test automation consultants supported by an architect, dev and test leads, and a UX designer. Now, these guys are readily available resources that come with an understanding of how to test properly and the knowledge of working closely with end customers. We put a BDD or behavioral driven development approach in place to help drive closer collaboration between the devs and the business and the shift testing left. And we also made expert software developers available in an on-demand basis for extension and creating new APIs in the back end. And you can sort of see from the comments here that the feedback was awesome. They actually said that our low-code teams played a major part in the digital transformation of their company. So just to summarize, we talked earlier about COBOL and how it got to the point where 30 years on, we still need expensive, highly trained engineers to support and maintain it. And this was because many companies dropped engineering best practice. COBOL programs suffered from a lack of design and proper testing, which led to mounting technical debt, making them more and more unmaintainable. But just like us, you can get low code to work for you. And my tips are today, first of all, apply the rigor and discipline and process of engineering best practice and do things right. Make sure you pick the right low code platform, especially one that supports export or source control integration and configuration management, and understand the operational overhead and when you need to be hosting these applications for yourself. Or alternatively, you can just call us. We can help you to make the right technology choices. We can help you get the right best practices in place. We can even build the low code for you. We have the right partnerships, we have the right solutions, and we have the right people to help you out. So thanks very much for listening to me today. I hope that your low code journey is a lot more like this and a lot less like that picture I showed at the start. Do find out more. You can join us in the chat room after the talk. Read the latest Expleo low code blog on the Irish Tech News. I'll post the link after this talk, or connect with me on LinkedIn or via my personal website to listen to some more of my presentations. Thank you and have a good day.